All right. Hello, everyone. My name is up there, is Luca Bolognese. I'm a lead program manager for the LINQ project and the C# team in general. So, yeah, so that's who I am. The way this thing is going to go, I have a demo that runs for about 45 minutes. So I will spend time in slides just for 2 slides, and then we will write code all the time. I would prefer if you can save your questions for the end. I will try to leave 10 minutes or so at that time to answer them. So let's see if I'm able to do that. All right, so what is LINQ? Why are we so excited about this product? Why are we spending so much time and resources in this product cycle to come up with this thing? So we think that LINQ is going to change the way that you write code. This sounds like a marketing thing, and it is a marketing thing, but it is kind of true as well. The reason I say that is that we're trying to tackle in LINQ what we see as the main problem of people writing code today. If you are a programmer these days, your life is kind of good. Well, not as good as a CEO, I guess, but it's kind of good. I mean, you write code, you live in this golden world. You've got a debugger, you can set breakpoints, you can see your variables. You've got IntelliSense. You hit dot, you see all the methods on your object. So everything is nice and dandy for you. Your life is fun, as you know. So everything is fine and nice until you need to access data. And when that happens, things become completely different. Suddenly there is this black box there on the corner, and you communicate with these guys by sending strings. These might be SQL statements, or they may be XPath statements if you're working with XML. But the environment suddenly disappears from you. You cannot set breakpoints. You don't have IntelliSense. It's like suddenly having to work in a different language that you are not used to. And in your mind, you need to keep track of your object model that you know very well, and you need to keep track of the database structure or the XML structure. And you're there, and you feel like you're a plumber trying to put together one thing on one side and one thing on the other side, and try to make those two words as similar as possible. The way that I think about it is like is you are sailing, and there is the wind is on your back or your front, but there is a nice wind, the sea is nice and smooth, and you're sailing and you're all happy, and suddenly you die or something. that's an exciting thought. So something bad happens to you, and the same like a giant squid or something. And the same is true as you write code. You write code and everything is nice, and suddenly things fall apart because you're accessing something that is so completely different from your environment. And this is what we are trying to solve with LINQ. If we are successful, you write code and suddenly you have to access data, but you're still writing code and you don't even realize it. You are just continuing writing your code. And all the environment is still there for you. So that's the problem we are trying to solve with LINQ. So let's take this is my last slide. Then we go to demos. The first thing we did is to introduce queries as the first-class citizens in the .NET framework. So you've got the capability now. Queries are like types in .NET. They are intrinsically known by the system. And once they are there, then you can start to write to integrate them in your programming languages. So from inside C# or VB, you can now submit queries. Okay, so now you have queries in your programming language, but what can you query against? So there are three things. First of all, your object model. If you think about it, your object model is data. You've got collection of objects, and each one of those objects has fields and properties. It's really data. It's like a little database in memory, if you wish. And right now you are querying over this data, and you call these queries for each statement. So that's what a for each statement is. It's an iteration over data to find some of it that satisfy a particular characteristic that you're looking for. That is a query. It's just expressed in a very imperative way, in a do this, do that, do this, do that way, instead of in a way that is more similar to I want to achieve the following, in a more declarative way. So now with LINQ, you can query in such a declarative fashion over your objects in memory. Moreover, there are databases. Databases are where most of our important data is, and you can use queries in C# and VB to query directly against your database. You can with LINQ enable ADO.NET so that you can query over the dataset, over SQL Server, and over entities that are an higher level kind of representation of your data. Mike Pizzo is coming directly kind of after me, will be going into much more detail on those three pieces. But I will touch on them in this presentation. And the last thing that you can query against is XML. And from the point of view of the programmer writing queries, is just writing code. It doesn't matter to him, or it matters little if he's going against one of those, or the other of those domains. So let's go into Visual Studio. All right, what I want to do here is, this is Visual Studio in case you don't realize it. It is possible to bring Visual Studio in this very bare state. You have to go to Tool Options and uncheck a bunch of stuff. But if you do it, you'll never be able to bring it back to the way that it was before, but it is doable. So what I'm about to do, I'm going to write an application in C# 2.0, and then I'm converting it to C# 3.0 and showing you how LINQ enters the picture. In all my presentation, I'll be using snippets. Snippets are a way, for those of you who don't know them, they are a way for me to write just one word and a whole bunch of code gets generated. For example, I just write Gilgamesh, and this gets generated. So this is what snippets are. All right, so let's start writing code. So first thing, I'm using a bunch of usings for system and collections. This is the customer that I want to work on. You can see that it has a customer ID, a contact name, and a city. So the application I'm going to write does go against Northwind, and it manipulates customers. So the first object in my application is a customer. So then driver, static void main, and I need a bunch of customers to work on. They told me that you cannot see at the bottom of the screen, so I'll try to write everything in the first two lines at the top. So there would be long lines, but so all right, so what I'm doing here, I have a method that loads customers. So it creates a list of customer, it creates one customer, it adds this customer to the list, it does that a whole bunch of times so that I have plenty of customers, and then it returns my customer from the method. Okay, is that clear what I'm doing here? All right, so now I have a customer up here, and I have a collection of customers down here. Now, what I can do with this collection? For example, let's say that I want to return, to print out a report that has all the cities, but just the ones that start with the letter M, and it has the number of customers for each city. For example, it will be like Rome 35, Berlin 26. So let's say I want to do that. And I'm starting from that list of customers right there. So the first thing that I want to do, I want to create an object to represent my results. So let's call this guy result. And as I said, it has a city and it has a count that is the number of customers in this particular city. So now that we have everything in order, we can start writing code. So I want a list of results. Let's call it results equal new list of results. And I can do a for each over all my customers. So customer C in load customers. And then from these customers, I'm just getting the ones that live in a city that starts with M. So I'm doing if s.city.starts with M. So if it is one of those customers, then I will do this. And I'm going to tell you what it does. So if my customers is one that lives in a city that starts with M, then I'm looking in the result collection to see that if there is already a result for this particular city. You will see that this is a delegate that returns true if returns true if that result has a city that is the same as the customer. If I find the city in the result collection, if I don't, find the city in the result collection, then I'm creating a new result. I'm setting the city to be the city of the customer. I'm starting my counter, and I'm adding this result to the results collection. If instead there is already a result for that particular city, then I just increment the counter to say that there is one more customer that lives in that city. Okay? Are you guys with me? Not particularly obvious, but that is kind of my point. We will see later, you know. And you can claim that I can write it in a simple way by using a dictionary and stuff, but you know, that's about the way you write this sort of code. You know, a dictionary plus or a dictionary minus. That's kind of how you write it. So after I have my, you know, all my results, then I can print them out. Just for each over the results and printing them out. So let's see what happens. Yeah, so those are all my cities with. So it does work. I didn't make any error. Allow me to print things in a kind of a nicer way by using something called object dumper. And what this write method does, it just goes through my collection and uses reflection to print all the fields in my collection. This is not. The object dumper is not part of our libraries. It's just a sample code that you can download from MSDN. It took Anders Salzberg probably 1 hour to write it, so it will take me and you probably half an hour? No, probably much more than that. But that's what it does. I mean, it's exactly the same as the previous for each statement. It just adds color. So that's what it does. So, all right. So this is how you write this code. You may have noticed there is a certain machinery going on here. It's all very imperative. It's like you're talking to to a 2 years old. I mean, you're telling you, find this. If you find it, put it in this list. Then, I need to start a new list up there. I need to go and find stuff. It's almost like working at the assembly level, some years ago. This is not a query. Notice how it's different, what I have in my mind, which is simply, returns me all the city that starts with M, with their customer, how my mind is different from this code. And we will see how LINQ makes my mind, makes that simpler. Anyway. So, but now, first let's talk about new things in C#. First thing I want to do, I want to add a whole bunch of usings. The only one that I really need is this one. So I could have done just by adding that, but I want to add all of them so that then I'm not going back and forth adding usings during all the rest of my demo. Then let's take a look at this. You may have noticed that this is quite verbose. I'm not doing anything in my properties except returning the value of a field or setting the value of a field. And people do that all the time. So in C# 3.0, we have a simpler way to write that code, which is not this, but is this. So those are called automatic properties. And what's happening under the cover, the compiler is generating all that was on the screen before. It's generating a backing fields, it's generating getters and setter to set those fields. Okay, it's just that you don't need to do it yourself. So that's a new feature in C#. I could do the same with result, but I'm not going to do it because I will be using result in a different way later on. Then look at this. I have a list of results on both sides. I'm not going to go into details on those C# specific feature because I want to get to the meat of LINQ. But I just want for you to understand the code, at least to give you an idea of what's going on. So notice that I have list of results on both sides of this. So in the new release of C#, we allow you to say just var. And what happens with var is that the compiler is inferring the type of results by looking at the expression on the right side of the equal operator. Okay? So the compiler looks at this and says, oh well, results must be a list of results. And in fact, if I hover over this var, you can see that IntelliSense knows that that is a list of results. So this is not weakly typed code like you might have in Python, or this is still fully strongly typed. After this line of code, result is indeed a list of results. Okay, this is not an object or iDispatch or any craziness like that. It's still strongly typed. So I can do the same here, and it makes that code slightly simpler. Then if I go here, look how verbose it is to write a delegate. I need a syntax that goes delegates of result of R. Hello, guys. Result of R, and it's all very, very long. There is an easier way to write this, which is by doing this, r.city equal c.city. And this is a different syntax, what we feel a simpler syntax to write delegates. So I'm doing exactly the same thing that I was doing before with the more verbose syntax there. And if you go here and you look at this code, you will notice that I need to create a new result, that I need to set properties on those results, and it takes me 4 lines of code to achieve what I want. And now you can do the same in a single line of code, and we call this object initializer. And if you look at this code in a reflector, you will see that what I'm doing, I'm creating a new result and I'm setting all the properties. So essentially, it's a way for you to write simpler code but achieve the same thing as before. Again, we are trying to simplify how you do things. And this is called object initializer. And if we take a look at this list, again, you will see that I'm creating a new list. I'm creating a new customer. I'm adding this customer to a list. And again, in your mind, you have you simply want to add a bunch of customers to a list. And there is a way in the new release of C# to do just that by writing this code. So notice that I'm using object initializers to initialize a new customer, and I'm adding directly that customer to the list. So essentially, in one line of code, I'm doing what I was doing before in a large amount of lines of code. So those are all things that we did in C# 3.0 to make to kind of make your life easier. But if you have been listening to my initial kind of spiel on data equal object, at this point you might be feeling cheated. I mean, I've been showing you a whole bunch of small things here and there. You know, you can do this, you can do that. Now you can make this easier. Now you can make that easier. But the truth is that the root of the problem with the previous code is not in any of these things. The root of the problem is this. The root of the problem is that you have to express something that is so simple in your mind in all this very imperative way. You have to tell the compiler exactly how to do things. So the most important thing of LINQ is that it makes that code go away. And instead, the way to write that is to do this. You say from C in load the customers, where c.ct starts with m, group C by c.ct into G, select new result, not this, result, then you say ct equal g dot key, and count equal g dot count. And here I'm printing query. So all that code becomes this. And hopefully it does work as well. Let me, yeah, it still does work. So this is exactly what I was talking about. Look at how now, this is exactly what I want. I want all the customers. The way that let me explain you how I think about this code. The way I think about this code is first of all, I'm getting all the customers. From all those customers, I'm getting just the ones that starts with the letter M, with all the ones that have a city that starts with M. From those, I'm grouping them by city, right? So now what I'm getting is a array of objects that have a key and a bunch that is the city and a bunch of customers for that city. This is the group by as it is in SQL. And from that, I'm selecting out my new results. So this is, compared to the previous code at least, this is a much more declarative way of doing things. And notice that I'm not losing any of the strongly typedness of my program. When you do something like that and you go against SQL, you have no way of knowing if the table has really a key column, for example. But here, I can, if I misspell something, for example, I say CTD, like so, and I try to compile, the compiler is going to catch it. So it's all strongly typed now. And you might be wondering how this thing works under the cover. So I want you to focus on that. So this is very important to understand. The reason why this works is that this method, load customers, returns an I enumerable of t. Okay? Because it returns an enumerable of t, that means that it can be queried upon by LINQ queries. So if you think about it, almost everything in .NET, in the standard libraries, returns enumerable of t. And if you have libraries of your own that you have been writing in, in C# or VB or whatever, most likely when you have to return an array of objects or a whole bunch of objects, you are returning something that implements enumerable of t. So all your customers, without changing any of your code, can now query over your results. This is quite a powerful thing. It took a while for us to find a way to enable LINQ over all the existing collections that are kind of out there. But and everything works. This is the hooking point because this guy returns enumerable of t. So that's important to understand as we move to databases and other forms of queries. Okay, are you guys with me? Yep. You might be wondering what happens under the cover. The compiler takes this code and generates a whole bunch of for each statements. It's just that the compiler does it, it's not you. Okay, it's like rising the level of abstraction, even if it's kind of a marketing thing. But yeah, anyway. So, all right, so this code is still, there is still something that is not perfect in this code. There is still something that you might not like. And that something is, in my opinion, the presence of this class. Come on. Result. So notice that result is not a part of my domain model. There is nothing in my world called result. Result is just something that I had to introduce because I wanted data to be structured in a certain way. Right? In my model I have customer, I have orders, so I don't have result. So, but here I need that result thing. So let's remove it. So goes away from here and goes away from here. Let's see if it still runs. Yeah, it does still run. So this feature right here is called anonymous types. So what's going on is that you don't need to create a type for each result that you might want to retrieve. Okay? You can just say new and then put the shape of your type right there. And what the compiler is going to do under the cover is going to generate a type that has this structure, that has a city as a count properties, okay? And it's going to give a name to this type like underscore underscore something that you cannot reference that type because it's compiler generated. Okay? But everything is still strongly typed. So this is a real type. If afterwards you do a for each statement and you try to access, for example, a city2 property on this type, you're going to get a compile time error because there is a real type there. It's just that you didn't need to create it. Okay? This is particularly useful if you have a large application that has hundreds of queries. You don't need to go and create a type for each possible shape of your result. You can just use anonymous types and everything just works. Okay, so now the code is getting nicer here. There is still something that it's not too good in this code. So most often you don't really initialize your data structure like that. You don't hardcore your data in this way. You're loading your data from, for example, an XML file. So I happen to have an XML file that just matches that data. This guy, you notice that it has customer ID, contact name, and all sort of stuff. So let's see how, by using LINQ, I can load data from that XML file instead of just creating the the collection in memory. So let's remove this code here. So what I'm about to use now is called XLINQ, which is another component of LINQ. So I go and I say xElement.load. No, well, I say from X in xElement.load, and I'm loading from customers.xml, and I want all the elements in customer.xml. So what I'm doing here, I'm loading that XML file, and I'm retrieving all the elements. Then from each element, I'm selecting a new customer. And this new customer has a city, which is equal x dot attribute called city dot value. It has a contact name, which is x dot attribute contact name dot value. And it has a customer ID, which is about the same. Customer ID dot value. And let's close the right things. Okay, so let's run it to make sure that it does work. So now I'm loading all my data not from a collection, but from an XML file. But notice that all my query stays exactly the same. There is no change there. The reason is that this method, load customer, is returning an IEnumerable of customer in the end. So I don't need to change my query in any way. And notice what's happening here. I'm iterating over all my elements in my XML document, and for each one of those elements, I'm creating a new customer with those things. And so the end result of this query, it's a list of customers, because I'm creating new customers there. Okay? Notice how all the work of parsing an XML file and generating objects out of it, it's all done in one line of code, essentially. And that's the way that it should be, because it's just a simple things in your mind. It's just from this XML file, give me all the customers that have, that are there. And that's kind of what we are doing here in LINQ. Are you guys understand why this kind of cool? Yeah. Yeah. So okay. Again, this works well with XML, but maybe you have libraries right now that returns data sets. Will this work with data sets as well? Maybe you don't want to change those libraries at this point in time. So if you're going against data sets, let's look at an example of that. So this is a method that is using the SQL adapter to submit a query for all the customers. Then it's creating a new data table, is filling that data table, and is returning that data table. Okay? So now, if I go and I run this, so it still works as before. And again, notice that my query hasn't changed at all. So from a user of my API, I'm still using LINQ in exactly the same way as before. And the reason for that is that we made customers data table implements IEnumerable of whatever the customer in this case. So that from the point of view of this query, is still operating over a list of customers. So it doesn't care, essentially. And so all your code stays the same, even if now I'm loading from a data set, from actually a data table, instead of just objects. So let's just touch base on this. I've been showing you how you can write queries against your objects in memory, against XML, and against data tables. And how the query still stays the same. But what happens if you want to go directly? All those queries are executed in memory, right? Notice that here I'm in this code here. I am, I'm getting all the customers, and then I'm iterating in memory. So that's not the way that you want to submit your queries. You want the database engine to do all the work of querying and filtering and projecting and all that kind of stuff. And that is not happening here, okay? And it was not happening with your object in memory because they are object in memory. There is no query engine there. And it wasn't happening with your XML file. So, but what if you want to write that code? What if you have a database, for example, Northwind, and you want to write a LINQ application, so you want to do the same kind of queries and thing going against that database. How do you do that? So let's take a look. First of all, let me remove everything that is unnecessary. So let's remove this stuff here. And there is no load customers anymore. And let's say that I don't even have a customer. I don't even have a class that represents my database. So now I just have a database that I want to go and access. How do I do that? So I go to project, and I say add new item. I pick data, and I say link to SQL classes, and I call this guy Northwind, like so. And I'm presented with a designer surface, and I can go, and these are all my tables in my database. So this is Northwind. I can drag and drop things like customer, for example, orders. Notice how customer and how the tool immediately recognized that there is a one-to-many relationship here between customer and orders by looking at the foreign keys and primary keys in the database. And so while I'm dragging and dropping stuff, the tool is creating my object model under the cover. It's creating a class customer, it's creating a class order, it's creating a one-to-many relationship between customer and order in my object model. Okay? So I can also drag and drop store procedures. For example, sale by year. There is always a moment of panic when I do that. And that is not a good thing. Yes. And sale by category, for example. And as I'm doing all this stuff, what's going on under the cover is that an object model has been generated, and attributes has been put on that object model to tell the framework where this data is coming from which table the data is coming from. Mike Pizzo in the next presentation will be showing you all the attributes and everything, how it really works under the cover. But that's what's going on. And so if now I go back to my code, I can now simply say, Northwind data context, and this is a class that has been created by my dragging and dropping exercise, and then I can go in and I can say db.customers. Notice that all the tables that I dragged and dropped are now in IntelliSense. So there is a Northwind class that represents my database, and if I dot, IntelliSense shows me all the tables that are there. And so I can now go and execute this. And now I'm retrieving data from my database. Notice how my code couldn't be simpler than this. Let me prove you that I'm indeed loading data from my database, I'm adding this little log. This log is going to print out all the queries that go against the database. And so you will see that there is a query that is generated, and the query has a where clause. So I'm not applying all my filtering and everything in memory. I'm bringing all of this to the database engine for the database engine to execute. Okay? But notice how, from the point of view of the programmer, not much has changed. Right? It's still doing the same LINQ query, but now what's going on is very different. And the reason why what's going on is different is that, again, this guy over here, instead of returning an I enumerable of t, it returns an I queryable of t. Okay? So the compiler looks at the return result of this and sees, oh, it is an I queryable of t. So I better go and create an expression tree, an object model that represents the query, and give this object model to the iQueryable of t implementation. So the compiler itself has no idea that you are going against a relational database or what you are doing. The only thing that the compiler knows is, okay, this guy implements iQueryable of t. That means that I need to give to this guy something that represents the query. Okay? In our implementation, in the LINQ to SQL implementation, what's going on under the cover is that the framework just walks through this expression tree, constructs a SQL query, and sends the query to the database. But you can build your own implementation of iQueryable of t and do something completely different. You know, you can look at the query, go against a web service or go against Active Directory. The compiler doesn't care. The only thing that the compiler knows is that this guy is an iQueryable of t. I need to construct an object model and give it to him. Okay? You guys following? This is very important because it kind of separates the world in two categories of provider. One set of providers that they don't need to do anything. They simply returns I enumerable of t, and then the framework does all the rest. You know, it does for each, queries in memory and everything, and you don't need to do anything else. You just need to return I enumerable of t. But if you want to build something that has a, you know, if you want to build LINQ access to your own database or your own data structure that has a query engine in it, then you can return iQueryable of t, and then you are in charge to construct the query that goes to against your query engine. Okay? So that's one of the ways that we made LINQ pluggable. For example, this is LINQ to SQL that I've been showing you. When Mike Pizzo comes around, it will be showing you LINQ to entities that does a very similar thing. And the way that they do it is by simply implementing iQueryable of t. And then they go and they do their own thing. Okay? You may remember that I dragged and dropped store procedures as well. So if I do this, I can also see all my store procedure that I drag and drop. For example, I can say sale by category. And I can say seafood, and this. And if I now go and execute, you will see that the store procedure has been called, and this is the result of my store procedure. But from the point of view of the programmer, I'm just calling a method on my database. Okay, this is when at the very start of this presentation where I told you we want people to just write code and not thinking about, you know, that's what I mean. That's what I meant at that point. You know, this is still code. You still have breakpoints. It's still strongly typed. You know, you can debug into it and everything. But, you know, you are going against XML, relational, objects, or whatever kind of you wish. All right, so let's take a look at something else. Let's talk about LINQ to XML for a second. So LINQ to XML is a new XML cache I told you there is a lot of code in this presentation. Immediately after lunch, I understand it might be hard. But so let's say I say new X element, and I call this guy car, and then I want to print it out. I do this, XML, and this is the simplest possible way to construct an XML document. I can go and I can run it, and it is indeed an XML document. I may want to do something more. I can say car engine, for example, and I can go and run it. And now my car has an engine. Or I can make engine an element itself, for example, by doing new X element, engine, let's say it has, 2,000 cylinder or something like that. And you go, and now you got a car with an engine sub-element, and let's say that I want to make it an attribute. I can go and I say X attribute, and just by changing that word, I can go and now, now my element as an attribute. I hope you can see how working with this is much simpler than working with the DOM when you are creating things, again, this is the difference between working in an imperative way, which is the DOM, or working in a declarative way like this, when you just express what you want. And indeed, now that all this data gets in memory in a very similar way, I can really do cool stuff with this thing. I can go and say sales, and then I can query. I can say from S in db.sales by category, seafood, and this, where S dot total purchase is less than 5,000. And then I can start creating X element like this. And I can say sale. And then I can say new X attribute. And I can say product. And this is an S dot product. And then I can say new X attribute, total, and in the S dot total purchase. Now I close all the things there, and that's all I need to do. And think about this. Well, let me run it first. I run it, and now I'm executing a store procedure against the database. I'm returning the result, and I'm creating an XML document out of it. Let me cut and paste this, like so, because I will be using it later on. So think about that. Think about writing that code now. Now it's essentially 2 lines of, well, it's 4 or 5 lines of code. But think about writing that code now. You will be there creating a new command, assigning strings, well, it will be like this. I only like this part. So that's the same code. And it's not a problem of writing. I mean, you can get it right eventually. It's that the next guy coming after you try to understand what the hell is going on here. Right, I mean, so I posit that I just crashed my idea. No. I think this is understandable. And I'm doing exactly the same thing. Okay? So, all right. So this is all C#, and I'm a C# and a C# lead program manager. So you might think that I just, that all of this just works in C#, but exactly the same things work in VB. All of this demo, I could have done it in VB in exactly the same way. And indeed, VB has gone one step further. So let me show you what they have done. So let me open up my VB project and set it as the startup project. Now, you remember that I cut and pasted the previous thing, right? The previous XML that was generated. I can, well, I just copied, not cut. I just copied. Now I can paste it directly into the code. And I can go and print it like this. And now I can run it. And it prints out this. So what they did in VB, now you can have XML inside your code. As literals inside your code. You can write XML there. And it's not just a passive way to have some static XML. You can do things inside this XML. For example, let me show you. I can do dim name equal ravioli. And instead of escargot, I can go and do equal name. Notice this syntax. I'm inserting something like you do in ASP.NET, if you wish, inside my XML. And if I run it, now you see at the top I've got ravioli in my XML, which is a strange phrase, but that's what I got there. And think about it. So now I've got XML here. I might want to do transformation over my XML. I may want to create an XML that is different from this one. And indeed, I can use LINQ to do it. You're starting to get in the sense of how things are fluid now. Data becomes kind of part of your programming language. And now you can go ahead. Let's say that I don't like this XML. I want to create a different one. I want to create an order, for example, to represent all my sales. So I can go here and I can say from S in XML dot. This is a way to navigate inside the XML and get all the elements called sale. I can also do conditions here. For example, I want to test the attribute called total that is less than 2,000. For example, I may want to select some line items. And I want this line item to be S dot, well, for example, product. Okay? And then let's print this out. Right there. And if I print it, you will see that it just have the ones that are less than 2,000. But the point here is not this particular sensor. It's how data is fluid now. Data is inside. It might come from a database. It might come from XML. It comes from your own collection. You can query over it. You can project out of it. And things that before looked very complex and looked very, very difficult now are just one query away, if you wish. And in VB, XML is not even one query away. It's directly, it's there. I mean, all right. So we are almost done here. If you just remember three things from this presentation, those are the three things I'd love you to remember. That now data is indeed equal objects. Equal if you work in C#. But now data is equal objects. So there is that dichotomy, that black box that was there in the corner is not there anymore. Now is inside your program. And also the shifting between telling the compiler exactly what to do, all the steps, to tell him what you want to achieve. What's your final goal? And you will see in C# in the upcoming kind of releases that shift growing even larger. It would be even simpler to tell things to the compiler. And and then it does work against all those frameworks. So, yep, this is nothing, completely wrong, and this is completely wrong. This is good actually. This might be interesting for you. Those are all. No, this is not good for you. This is a different conference. So I'm done here. I'm opening up for questions, and thank you very much.